The first images looked routine. Another faint object moving against a backdrop of distant stars. At first glance, nothing suggested it would become one of the most discussed discoveries in modern astronomy. But as observatories around the world collected more data, that ordinary-looking point of light began to challenge expectations. Every new observation added another layer of mystery, and within weeks scientists found themselves asking questions they had never expected to ask. Today, this interstellar traveler, known as 3I, Atlas, has become the focus of one of the largest international observing campaigns in recent history. As it sweeps through our solar system, researchers are racing to learn everything they can before it disappears forever into deep space. The opportunity is brief, and once it is gone, humanity may never see this particular visitor again. Unlike planets or ordinary comets that spend their lives orbiting the Sun, this object arrived from somewhere beyond our solar system. Its path reveals that it is not gravitationally bound to the Sun. Instead, it entered from interstellar space, passed through our cosmic neighborhood, and will eventually continue its journey toward the stars. That alone makes it extraordinary. Only a handful of confirmed interstellar objects have ever been identified. Each one offers an incredibly rare chance to examine material that formed around another star, potentially billions of years ago. Every observation provides clues about distant planetary systems that no spacecraft has ever reached. When astronomers first detected 3I, Atlas, calculations quickly confirmed that its orbit was hyperbolic. This wasn't simply another long-period comet returning after thousands of years. Its trajectory showed that it had never belonged to our solar system at all. Its speed immediately attracted attention. Moving at hundreds of thousands of kilometers per hour, the object was traveling too fast to have originated from the Sun's family of planets. Gravity could bend its path, but it could not capture it. It was simply passing through, carrying with it a history written around another star. That realization transformed what might have been a routine discovery into an international scientific priority. Major observatories across Earth immediately scheduled observing time. Space telescopes joined the effort, while astronomers using optical, infrared, and radio instruments worked around the clock to collect every possible measurement. Since the object would only remain visible for a limited time, every hour mattered. The first detailed observations produced intriguing results. Instead of behaving exactly like familiar icy comets, 3I, ATLAS displayed characteristics that prompted scientists to investigate more closely. As sunlight warmed its surface, clouds of gas and dust expanded around its nucleus, forming the glowing envelope known as the coma. Spectroscopic observations suggested that carbon dioxide played a significant role in its activity, while the amount of water detected appeared lower than what is commonly seen in many comets closer to the Sun. For planetary scientists, that was fascinating rather than alarming. Objects that form in different stellar environments can possess very different chemical compositions. Temperature, radiation, and the materials available during formation all influence what eventually becomes frozen inside a comet-like body. An unusual mixture doesn't automatically indicate anything artificial. It simply reflects a different cosmic birthplace. Still, the chemistry was interesting enough to spark intense discussion. Researchers compared the object's spectral fingerprints with thousands of previously observed comets. Some similarities appeared, but so did several notable differences. Each new dataset refined their understanding while also revealing fresh questions that could not yet be answered. Attention soon shifted from composition to appearance. As the object approached the Sun, high-resolution images revealed changes in its dust tail. Like many active comets, its appearance evolved as solar radiation and charged particles interacted with material escaping from its surface. Certain viewing angles even created visual effects that made the tail appear to point toward the Sun, a well-understood phenomenon known as an anti-tail that depends largely on geometry rather than the actual direction of material flow. Although visually dramatic, such effects remind astronomers that perspective can sometimes produce surprising illusions in space. Meanwhile, infrared observations allowed researchers to estimate surface temperatures and examine how efficiently the object absorbed and released heat. Those measurements helped scientists model the physical properties of the nucleus, including its size, density, and rotation. Every answer generated new mysteries. The object's brightness changed over time, suggesting that it was rotating while jets of gas erupted from different regions of its surface. These outgassing events can create tiny forces that slightly alter a comet's motion, making precise trajectory calculations increasingly challenging. Such non-gravitational effects are well known in comet science, but measuring them accurately for an interstellar visitor is particularly valuable because researchers have so few examples available for comparison. The scientific excitement surrounding 3I ATLAS soon spread beyond observatories. News reports, online discussions, and social media transformed the object into a global topic. Alongside careful scientific analysis came increasingly dramatic claims. Some suggested the visitor was unlike anything nature could produce. Others speculated that it might represent technology from another civilization. Most astronomers urged caution. Extraordinary discoveries deserve extraordinary evidence. While unusual observations naturally invite creative ideas, science advances by testing every explanation against measurable data. The overwhelming majority of researchers continue to examine the object as a natural interstellar body until compelling evidence suggests otherwise. Even so, the debate captured the public imagination. Every new image released by professional observatories fueled another wave of discussion. Some viewers focused on its changing brightness. Others pointed to its unusual chemistry or its remarkable journey across the galaxy. Each observation reminded people that our solar system is not isolated, it exists within a vast cosmic neighborhood where material from distant stars can occasionally cross our path. As 3I ATLAS continued its approach toward perihelion, the point of closest approach to the Sun, astronomers prepared for the most important stage of the encounter. The increasing heat would trigger stronger activity, revealing fresh information hidden beneath its surface. Instruments around the world were ready to monitor every change, hoping to capture data that could answer long-standing questions about the formation of planetary systems beyond our own. No matter what researchers ultimately discover, one fact is already certain. For a brief moment in cosmic history, humanity has the opportunity to study a traveler that began its journey around another star. Whether it proves to be an unusual comet, a fragment of a distant planetary system, or something that challenges existing theories, 3I ATLAS has already reminded us how much of the universe remains unexplored, and how every visitor from the depths of interstellar space has the potential to expand our understanding of the cosmos.